All right, so we are going to be doing 732, and today we are going to be using the distributed property. So it says, today you will consider a more complex magic trick. The table you use to record your steps will have only 2 trials, but it will add a new column to represent the algebra tiles with an algebraic expression. So kind of same thing, only this time we're only going to be running 2 trials. And instead of just looking at the algebra tile pattern or pictures, we're also going to be writing an algebraic expression for each piece. Okay, because in life, you're not always going to get these tiles. You're going to have to work with the expressions. So let's go ahead and look down here. Pause the video and go ahead and run this trial, or run these 2 times and see what you get. Okay, so I'm going to choose 4 first. So 4 plus 7 is 11. Triple that, which is 33. Add 9, that gives me 42. Divide by 3, which is 14. And subtract my original number, which was 4. So I'm left with 10. All right, I'm going to try a different number. I'll go with 2. Add 7, which is 9. Triple the result, 27. Add 9, which is 36. Divide by 3 is 12. And subtract the original number, which was 2. So I'm left with 10. So I can see that this math magic is going to give me 10 every time. And if you look over at your algebra tile picture, you can see that we do in fact just end with 10 unit tiles. So no matter what number you plug in, you should always end with 10. Okay, so we're going to use this logic, but we're going to build just an algebraic expression. Okay, so we're going to be using variables and whole numbers. So here it says algebraic expression. We just have an x. Okay, remember, we don't know what that person's going to choose, so we defined an unknown number with a variable. So we're going to kind of build off it each step. So the next step says to add 7. So I'm adding 7 to whatever number they chose. So that's why I would write x plus 7. Then it says triple the result. So I'm multiplying by 3, but I'm multiplying that whole thing, that whole x plus 7 by 3. So I'm going to write it like this. Because I have to figure out, order of operations, I'm going to have to do what's inside those parentheses first, then multiply it by 3. And that makes sense because if I look at the order in which this trick is going, I had to do x plus 7, and then I multiplied it by 3. You could also use the distributive property, and hopefully we remember what that is, but if not, you take what's on the outside of your parentheses and multiply it by all the parts on the inside. So I'm going to take this 3 and distribute it to my x, so 3 times x is 3x. Then I'm going to take my 3 and distribute it to my 7, so 3 times 7 is 21. So those are 2 different ways that you could write that. And then add 9. Again, 2 different ways that you could do this. You could say that this is 3 times x plus 7 plus 9 and just kind of keep building. Or if you added 9 to the bottom one, remember, combine like terms. I cannot add 9 to my x because 9 doesn't have an x attached to it. I can only add 9 to my 21 here. And that makes sense again. So let me write that real quick. You can check that looking at the tiles. You have 3 x's still. And when you added 9, you ended up with 30 unit tiles. Sorry, I forgot to write that out. Okay. So this is 2 ways to write this. So that's why I'm going to put or so you don't get confused. and then divide by 3. So we're going to take, and I'm just going to use this bottom little simplified expression, and I'm going to divide it by 3. So you could write this as 3x plus 30 divided by 3. Remember that fraction bar means division. And we can actually simplify this expression. We can divide 3x and 30 by 3. So when we do that, okay, we have to divide our 3 by all parts. So 3x divided by 3 is just x. Okay, those x's, 3 divided by 3 is 1, so they kind of cancel out. Then I take my 30 and divide it by 3, which just gives me 10. So then from this step to the next, I subtract the original number, and remember our original number was x because we don't know what someone's going to pick. So we got rid of the x, which just leaves us with 10. So that is how you would write an expression for that. All right, go ahead, flip to the back. That I didn't know I had the answers right there. So we are going to kind of reverse our thinking. It gave us the algebraic expression, and now we need to write the steps. So we are going to do so. So for A, right here, it says describe the steps 1, 2, and 3 in words. I'm just going to draw an arrow because I'm just going to write them up here in the table. And I am going to type these so it's a little clearer. So step 1, we just have an x, which means pick a number. Okay, if I came up to somebody, I need to tell them, pick a number. That's how this all starts. Then I can see all of a sudden I went from just having an x to an x plus 4. And I can see that's plus 4. So that tells me I'm going to add 4 to whatever they chose. Then you're taking that x plus 4 and you're multiplying it by 2. Oh my goodness. And so right here, it's probably going to be a little easier to look at this in the distributive property. Because you can see in this next step, we have 2x. Well, in order to get that, we would have distributed this 2. So to better see this, I'm going to simplify this expression real quick. So we're going to distribute our 2 to both parts, and when we distribute, we multiply. So 2 times x, 2x, and 2 times 4 is 8. And that helps us because I'm going from 2x plus 8 to 2x plus 20. So what did I add to get to 20? So I would have added 12. Okay, because remember I have to add it to my whole number, or my constant, not my number with my variable. Then from here, okay, I went from a 2x plus 20 to just an x plus 20. So I got that x by itself. And I got to figure out, okay, what did I do there? Okay, well, 2x really means 2 times whatever x is. So in order to get x by itself, I need to undo that multiplication, which means I divided. But what did I divide 2x by just to get x? And remember, that's technically like saying 1x plus 10. Well, 2 divided by 2 is 1, right? And 20 divided by 2 gives me that 10. So I know that this step is divide by 2. And then I got rid of my x. So now I'm just left with 10. So you're going to subtract the original number. So go ahead, pause, and run 2 trials to see if you do in fact get 10 each time. Okay, so I'm going to choose 2 first. Add 4 is 6. Multiply by 2 is 12. Add 12 is 24. Divide by 2. is 12, and subtract my original number, which was 2, and I got 10. Let's go ahead and try 4. Add 4, which is 8. Multiply by 2 is 16. Add 12 is 28. Divide by 2, which is 14, and subtract my original number, which is 4, and you do get 10. If you chose different numbers, it should not matter. You should get 10 every single time. All right, it says look at the algebra tiles used to build step 3. Write a different expression to represent those. We actually did that. So we went from, this is what we were looking at originally, and you can rewrite that by using the distributive property. So we distributed the 2 to the x, which was 2x, and then we distributed the 2 to the 4. So that is another way you could write that. What tiles do you have to add to build step 4? So when we went from 2x plus 8 to 2x plus 20, if I was building that with tiles, what would I add? Okay, well, we added 12, so we would add 12 unit tiles. It's important to be specific there. And then complete 2 trials, we already did that. Because if I just said add 12 tiles, I could add 12 x tiles. I could even bring in an x squared tile, okay? You want to be specific. You are only adding 12 ones. All right, last question. It says, in step 3 of the last magic trick, you rewrote the expression 2 times x plus 4 as 2x plus 8. Can all expressions, like 2 times x plus 4, be written without parentheses? For example, can 3 times x plus 5 be rewritten without parentheses? Build 3 times x plus 5 with tiles and write another expression to represent it. Does it work for all expressions? Okay, so we are going to go ahead and build what this would look like. So what this is saying, and remember, multiplication means of, or of means multiplication. So if I want to relook at this, I could think of this as 3 of x plus 5, or 3 groups of x plus 5. Okay, that's what this means. So 3 groups of x plus 5. Here's my x, and then 1, 2, 3, 4, 5. There's one group. And then my x, 1, 2, 3, 4, 5. There's 2 groups. And then my third group here. 1, 2, 3, 4, 5. Okay? So, how could I write that out? Well, how many x's does that give me? So that gives me 3 x's. And then how many units? Well, 5 times 3 is 15. So 3x plus 15 is the same thing. Again, if you distributed the 3 times x is 3x, and 3 times 5 is where I got my 15. So if you need to draw it out, that is how you would do that. So to answer the question, it works for all expressions where 2 or more terms in the parentheses are multiplied. Oopsies. By a number. So it will work for all expressions. All right, and that is 7.3.2.